Hey, today is a 3D shape kind of day. That is what we talked about in class today. So if you missed class or you missed some info or whatever, then that is probably why you're watching this video. But there's a couple of things that I want to share with you and just explain to you, okay? So first of all, our 3D shape started today, and we started with prisms. And so prisms are actually really amazing shapes, and most of the prisms that we see in real life, you're very used to, right? So like the tissue box, right? This is a prism, okay? And I'm going to tell you what a prism is and define the prism for you in a second. Let's see. Oh, this is not the best example, but cylinders, right? Coke cans, that is a prism. Here's a roll of toilet paper. This is a prism, okay? And so basically what a prism is a three-dimensional shape that has two bases that are the same. And so toilet paper, the base is a circle, right? That tissue box that I had held up, the bases are the same. So maybe the bases are squares, maybe the base is a rectangular shape, okay? But that's what a prism is. So one of the first things that we did in class is we actually experimented a little bit with GeoGebra. So that's what I'm going to do with you right now. On GeoGebra, if we created a polygon, so we're actually going to make a triangular shape, okay? And then what I'm going to do is I'm going to duplicate this shape, because remember, a prism, right, has two bases that are the same, okay? And then each corresponding point or position on that shape gets attached with straight lines, okay? And so this is a triangular prism. So if I were to, say, move this around, right, again, the bases are staying the same. Those triangles are staying the same, okay? So again, if I move it around, you can see, right, this triangular prism, okay? The other thing, again, I'm going to make another one for you. So let's go make a pentagon, okay? And so same thing, right? A pentagon is the same thing, right? The shapes are the same. We can connect each of those corresponding pieces with these straight lines. And then again, like I said before, you can manipulate a little bit and kind of see what is happening as the pentagon changes shape. So check that out, right? And it does look a little bit weird when you kind of move it around a little, but yeah. So that's what a prism is, okay? A prism is where the bases are the same, like I said, and then it's connected by these straight lines, okay? So what we're going to be doing today is finding the volume of those prisms. Go get your workbook, page 259. All right, so when you're finding the volume of prisms, most of you already know one of the volume formulas. Most of you already know length times width times height. So if you look over here at number 2, that is what you're going to do, is length times width times height. But I'm going to change the formula on you and make it a little bit different, okay? The formula for every single prism, okay, is V equals, and there's a capital B. I'm just going to make this a little bit bigger for us. There's a capital B and then a lowercase h. And here's what it stands for, okay? The capital B actually stands for the area of the base. So remember how I said before that there were two bases, right? And so that's what the big capital B stands for, the area of the base. So again, if we look at this rectangular prism, right, this box, most of you know that it's length times width times height. Well, guess what? The area of the base is a rectangle, and the area of a base, you would do length times width. And so that is where that formula comes from. It actually originates from this formula right here, okay? So when you go to do number 2, you're going to do, again, the area of the base, so 14 times 9, and then times the height, which is 6, okay? Please make sure when you are doing this that you put all of your work, so tell me what you're going to type into the calculator in here. That way, if you do end up getting something wrong, maybe you just had what I call fat finger syndrome, right? Where you go to type in a number and your finger's just too fat and it hits like both, the 5 and the 6, okay? I call that fat finger syndrome. So, okay, so that is number 1. Or number 2, I'm sorry. If you look at number 1, right? Number 1 is a cylinder. And so we need the area of the base. Remember, the base, right, is the bottom or the top, okay? Either one, you can flip it over. But for a cylinder, with the circle, the area formula is actually pi r squared, right? So it's pi times the radius and then squared. So DocHub, which is what I'm using, actually doesn't do exponents. It won't let me do like a superscript, so I'm sorry about that. But yeah, so you're going to do pi r squared, okay, because that's the area of this base. And then you're going to multiply it by the height, which is 5, okay? So again, make sure that you are telling me what you are typing into the calculator. So the volume is going to be 3.14, that would be pi, right, times the radius squared, so 3 squared, which is 9, and then times 5, okay? When you go to look at number like 3, for example, okay, so number 3 is a cylinder that's just like leaning, almost like the Leaning Tower of Pisa, right? That formula is still the same. It's still the area of the base times the height, okay? Let's see, what else? Dun, 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 dun. Oh, number 4, okay? So number 4 actually gives you some information, and you have to go figure out what the radius is. You're going to kind of be doing things a little bit backwards. And so if we use this formula, right, V equals base times height, area of the base, I know that my volume is 100, and that's going to equal the area of the base, which is 3.14, right, times my radius squared, okay, and then times my height, which is, in this case, 12, okay. I just want to move these around so we can see this a little bit better. Again, I apologize. DocHub doesn't let me do those superscripts, okay. So what we have to do now, though, is we actually have to go solve this equation. So I'm going to go multiply in my calculator 3.14 times 12. Okay, and I get 37.68. So I know that 100 is equal to 37.68. Whoops. Look, I just had fat finger syndrome when I was typing in, right? Times my radius, and then squared. So now I'm just going to go divide both sides by 37.68. So when I type into my calculator 100 divided by that decimal, I'm going to get a 2.65. Okay, so that so far is what r squared equals. And now we're just going to take the square root of that. So remember, when it says r squared, right, to get r by itself, you do the opposite. So the opposite of squaring is square rooting. And so this final answer should be r equals, let me get that typed into my calculator. Ba-bam, 1.6. I think it said to round to the nearest 10. Okay? Number 5 is going to go the same way. Number 6. Be kind of careful with number 6, right? You're finding the volume of 2 things. So you're going to find the volume of this, this like leaned over box, okay? You're going to find the volume of this. You're going to find the volume of that little Leaning Tower of Pisa. And then you're going to add those 2 volumes together, okay? If you take a look at number 7, we have this cylindrical shaped hole that is cut from the center of the cube. So it's like a little tunnel. You can like crawl through there. So you're going to find the area of the box, and then you're going to subtract the area of that cylinder that is inside there, okay? During class, we actually went through and did 1, 2, number 3 we talked about, and then we did number 4. So your assignment is to go finish this page 259. I know it's getting to the end of the school year. If you choose, you can do page 260 for extra credit. Even if you only do a little bit of it, you still can get a little bit of extra credit, okay? Speaking of the end of the year, there's something else that I want to show you, so hold tight. All right, so the last thing I wanted to share with you really quickly is what the end of the school year is going to look like for you. So this is your calendar for geometry, just to kind of give you a heads up of what's going to happen. So Monday and Wednesday, or Tuesday and Wednesday, we did math testing. Today we're doing prisms. So today and tomorrow, prisms. Next week, we're going to talk about pyramids, right? Like those great pyramids, right? But we're going to be finding the volume of them. On Wednesday, we're going to do the volume of spheres. And then Thursday and Friday, we're going to take a pre-AP test. We'll talk about that in a little bit more detail when we get to it. But I will tell you that it is going to count as a participation grade, okay? So it's going to go in, either you do it or you don't do it, okay? Just a quick heads up, Sunday night, the 16th, that is your last possible day to turn in missing assignments for fourth quarter. I will not take them after that day. Starting on Monday, the 17th, we're going to be doing a final project, and your final project is going to be a lot of 3D stuff, which is why we're talking about 3D shapes right now. Your final project will be due on Tuesday, the 26th by midnight. If your project is not turned in at that point, I will grade it on Thursday and Friday, but the highest grade you can get is a 60%. So I did just want to go over that with you, give you an idea of what's happening for the last little bit of the school year. Fat lady ain't singing yet, right? And it's not over until she starts singing. All right, send me an email if you guys have any questions. See ya.